This is Daniel Coosbury, and in this video, we're going to talk specifically about sampling and how to do it and what makes a good sample and a bad sample. And the reason why we are starting with sampling is because, as I mentioned in the last video, statistics kind of follows this diagram that I probably will write a little too often on these videos. But we have this idea that there's a population of interest, and we want to learn things about this population. And so because we never really know what's going on with all the members in the population, we draw a sample, and we use information about the sample to make inferences about the population. And so the content in this video is important because there are good ways to draw a sample in a way that's going to make the statistical methods work well. And there are bad ways to draw a sample in which they're going to make our inferences not very good. And so we'll look at these broad categories in this video. Okay, the first one and probably the most basic form of sampling is called a simple random sample. And I'll tell you, probability and statistics, they go together. Because statistics works really well if things are random. I thought I'd be able to underline with this pen. This is atrocious. I apologize. But a simple random sample is defined by this. If it has n things in it, it is a sample in which each collection of size n from the population has an equal chance of being selected. So imagine a big pond full of fish. You catch 5 fish. You throw them back in. You catch 5 more fish. It's a good example of a simple random sample. Let's just assume all the fish are the same kind and the same size maybe. But anyway, and that your first group of 5 fish that you caught, you had the same chance of catching them as you did the second group of 5 fish. It makes it incredibly random. It's simple and random because all the samples of the same size have an equal chance of being selected. So that's what makes it random. We use the word biased to imply things are not random. So when things have an equal chance of being selected, they're not biased. But when they're not equal, we call them biased. So here's another example. Imagine that old book movie, Willy Wonka. He's hidden 5 golden tickets and 5 Wonka bars, and then he throws those Wonka bars into the mix of all the other Wonka bars. He mixes them up, and they're just randomly dispersed in there, and then he sends them out to all the stores. And 25,000 children each bought a Wonka bar, and only 5 of them found a golden ticket. This is a good example of a random sample because those 5 children had just as good of a chance as getting one as a different group of 5 kids. Now, this is ignoring some details in the book, like that one person who bought like thousands and thousands of them. In my example, each one of these children are buying exactly one, which makes it a good, simple random sample. So everything, your samples of size 5 or size n each have an equal chance of being selected. That's what makes it simple and random. And here's a not example. Here's a statistics instructor who needs a random sample of technical college students to answer a survey. Let's just say she needs 30 people to answer this. And she decides, hey, my class has 30 people in it. I'm just going to sample these 30 people in my class. And that should give me a good representation of the whole college. Well, this is not a simple random sample. And my question is why? Well, if the goal is to learn about the entire population of the college, and she literally just takes this one class, and I'm kind of drawing this different than I did that little circle, but she takes this one class right here, and that's the only bit for her sample. Is that one class going to give you a good representation of the whole? Like, does the whole college take statistics, for instance? No, not really. Do all the majors require statistics, or even all the college? Like, no, not really. And so this is really a bad sample because the sample's biased towards the students who would need to take statistics, whether that's a good thing or a bad thing. Point is, it's not accurately representing the whole college. A better way to do this might be to go to this class and pick a few people, or go to this class and pick a few people out. You want this to be random. You don't want to be biased towards statistics students or something or other. So this is not a simple random sample. This is actually an example of a convenient sample. So a convenient sample is a sample that is drawn. It's not drawn by a well-defined random method. So the reality is this is not a random sample at all. And for statistics to work, we want things to be random. So this is not random. A convenient sample is really something we do because it's convenient, and there might be situations where a convenient sample works. For instance, I heard an example about a brick mason who he had a big slate of bricks and he was measuring how brittle they were, but they were in these big stacks of bricks, and I don't know, maybe there's no way I'm going to be able to draw that with this pen, but maybe they were in the bricks themselves were in bricks, and to do a good simple random sample, he'd have to randomly select bricks from this huge block of bricks. But pulling one out of the bottom would be really hard, or pulling one out of the second row would be hard. So he instead decided to randomly pick them off the top. That's an example of a convenient sample. So in other words, he would pick like that one and that one and that one because that was like easier to do. It was more convenient. This might be okay because there's a sense of randomness to them. So this might be an example of a good convenient sample, but for the most part, convenient samples are bad. There are better methods. So let's look at a few other methods. In a stratified random sample, the population is divided into groups or strata. Then a simple random sample is drawn from each stratum. So we're using the word stratum in place of groups. So this means the same thing. Groups and strata mean the same thing. Stratum is one group. So let's look at an example. Interested in hearing the opinions of Americans everywhere, a congressman randomly polls 30 people from each state in the United States. This is an example of a random sample because he's breaking the entire country up into states. So rather than just randomly picking hundreds of people from the country, he's picking 30 people from this state, 30 people from this state, 30 people from this state, and 30 people from this state, and so on and so on. So he's getting a good representation of the whole, like, people everywhere by breaking the country up into groups to do that. Now, one thing that's not well represented in this slide, you can have a stratified random sample and a perfectly good one, even if all your group sizes are not the same. So you could pick 30 from one state and 20 from another state, and maybe this is California and you want to pick a lot more people, and you can do that as long as you randomly pick them from the state. You can do that and have a perfectly fine random sample, stratified random sample. So just because I had 30 from each state doesn't mean that's how it has to go. You can get different size groups, but you can just imagine, like, that's kind of how our Senate isn't random, but like our Senate was made up of, let's pull 2 people from each state to represent the country. A cluster sample is a little bit different. It's going to sound the same, and on the next slide I'm going to highlight the differences. But in a cluster sample, we're going to divide the population into groups, just like in the last one, but we're going to call the groups clusters so we don't get this confused with the strata in the last slide. So we're going to divide everybody up into clusters, and then a simple random sample of clusters is taken. Finally, information is collected from every member in each cluster that was selected. Okay, so I'm going to try to draw a picture that works. Well, I'll draw a picture on the next slide. But here's the example here. And because it's too costly to travel all over the state, a pollster randomly samples 3 counties from that state, and he polls every single household in that county. So the big difference between cluster sampling and stratified sampling is you're breaking them into groups in both cases. But in stratified sampling, you're picking out a random sample from each group, whereas in cluster sampling, your random sample is of the clusters, of the groups themselves, and then you're going to sample all the people or all the things in that group. So I know that's a little confusing. Let me see if I can illustrate this with a few pictures. So this is going to be a stratified random sample. Okay, do you see my groups? In a stratified sample, I'm breaking the entire population up into groups, and then I'm sampling some people from each group. And the people I pick in the groups are getting picked at random. So that's the random part. Random is good. We like random. All right, that picture used to look good. Now I just scribble all over. But that's my whole sample, 2 from each group, for instance, or 2 from one group, 3 from another. That's a stratified sample. In a cluster sample, let's just assume this is the same population. So there's still 10 groups. I split them up into groups first, and then the random thing comes in when I'm going to randomly pick a few clusters. So I'm going to randomly pick this cluster. I'm going to randomly pick this cluster. I didn't plan this out ahead of time. It's completely random. I'm just picking some. So those 3 darkly shaded clusters are the ones I'm picking. In cluster sampling, you break them into groups, you randomly pick those clusters, and then you sample all the people in those clusters. So in that last example, that pollster, instead of traveling around the whole state, he randomly picked 3 counties and then went to every single household in the county. So you see, that's very different than stratified, because I'm not getting everybody from this group and this group. I'm getting just some people from this group and some people from this group. Here, I'm randomly selecting the groups, and then I'm getting everybody. So that's the big difference. Then there's systematic sampling. This one's not too hard to get your head around. In systematic sampling, items are arranged in order, and every kth item is chosen to be included in the sample. So K just represents a number. It can be every 5th item or every 10th item, whatever number you want. When I think of systematic sampling, I think of a phone book. So imagine a pollster is going to poll people. He goes through the white pages of a phone book, and he decides, I'm just going to dial every 20th phone number I see. And so she does that, and she gets a nice, it's a fairly random sample, because there's not a lot of bias in systematic sampling. But rather than calling every single number, she's calling every 20th number, which is it'll be a lot quicker. It'll still take a while. But that's a systematic sample. So you arrange everything in order, and then you pick every 2nd one or every 5th one or every 100th one. It makes it systematic. The last type we'll look at is called a voluntary response sample. And I don't have too much to say about this, but you get these a lot when you're doing mail in a response or call in a response. If you don't insist people do things, and you just say volunteer, come in and answer questions, it's called a voluntary response sample. These samples are often biased. There should be a D there, biased, and they're hardly random. And they're biased because volunteers tend to have stronger opinions than those who don't volunteer. So if you just shout from the rooftops, hey, come answer our survey, we're not going to pay you anything, just volunteer if you want to. Most people who don't care about the issue just won't come at all. But the ones who care might be the ones who volunteer. Also, people with negative opinions are more likely to volunteer a response than people with positive opinions. Think about the last time you called customer service for any reason. It was probably because you were angry about something, not because you were so satisfied that you just had to tell somebody at customer service. I think this is a true thing. But anyway, the point is that if you do a voluntary response, you just ask people to come, it's possible you get a lot of more naysayers than you do the opposite of that. So this is a thing. I mean, it can be random. I don't think it's random. I think it's biased. But anyway, so that's the end of that. Those are the different kinds of samples that we'll do. The big takeaway from this is distinguish these different kinds of samples, but keep in mind the ones that are really random. So we want simple random samples when we can. Sometimes stratified samples are nice because you get a good representation. Those are random. Cluster samples tend to be random. They're not quite as good, but cluster samples are usually cheaper. If we only have to go to 3 places, it's usually cheaper than going everywhere. But keep in mind, we want random samples to make statistics work well. In order for our sample to really tell us about the population, we need something random. So I guess that's my soapbox.